And now finally, your curve sketching menu. And I would say this is one of the most important little summaries that you will need to learn. The emphasis on graphing in this whole course, not just this chapter, but across the whole course, is massive. And like I've been saying to you, the better that you are at graphing, the easier many of the concepts will be for you to understand. Apart from the fact that you will get many questions that actually straight out ask you to draw a graph. So you have to perfect the ability to draw graphs, and to have a little like this is process or summary to follow is a good way to start. And it's always good to know you can fall back on this. So step one, I would say, if you're sketching a graph just because you want to develop a graphical understanding of what's going on, or because a question has instructed you to draw a graph, number one, you can save yourself a lot of time by simplifying the function. Take a close look at how the function's written. And there are times when it's written just to catch you out on this very concept, that if you attempt to graph it in the form that it's presented, then you're making it extremely difficult. Whereas maybe some very quick simplification, I've even seen at times it's brought the graph back to something you recognise as a straight line. Maybe a straight line with 1 point of discontinuity. So please be aware of that and always do it. So step one, always simplify the actual function if it is possible. So please don't jump straight into tables of values or what you've previously done in order to draw a graph. And if you haven't had a method for approaching sketching graphs, then let this be your method from now on. So simplify if you can. 2, establish your domain. Establish the X values that are relevant to your graph. Think about that. Think about this concept, domain, X values. I guess for so many years, the graphs you drew had a domain of all real X because they were just straight lines and parabolas, which has a domain of all real X. Then you didn't really consider that there were there were graphs that had a restricted domain, restricted X values, except I guess if you thought more about a circle, you'd realise that a circle only encompasses a very small range of X values, and it's the same with the Y values and the range. So establish that. Now, you'll know that you'll have restricted X values if your function contains a fraction, because if it's possible that that denominator is ever 0, the function will not exist at a point, an X value that creates a 0 in a denominator. So you need to establish that and identify it and make yourself write it down. I clearly identify that at the very beginning. Draw yourself a little sketch. So if you've identified that this graph is not going to exist over here at some X value, draw this. And just to keep you on track. Sorry about that. Just to keep you on track for how your graph or your sketch is going to look in the end. Step 3 says symmetry. Check the symmetry. That is, check whether it's even, odd, or neither. Do you know, this is probably the only place where I deviate from this menu. Sometimes it's not all that time efficient to do that. By the time you've gone through the process of establishing whether this graph is even, and if it's not, then you've tested odd, and then you're really no further ahead to establish that it's neither even nor odd. Sometimes, if the algebra is complicated, it's probably not that time efficient. I think there are other things that we can focus on that are going to help us get a picture of what our graph's going to look like other than this odd and even. However, there will be times when, if you had just realised that it was an even function and all you did was graph it for the positive x values and then realised that the negative x values was just a total reflection of that, then that, of course, obviously would be a shortcut and make your graphing easy. Something to be aware of, but I don't know that it is sometimes, like I've said, they're time efficient. Step 4, intercepts, definitely. And you know the little blurb now. Y-intercepts occur when x is naught, and x-intercepts occur when y is naught. And write these down and go through that process. There's always something that you can do towards establishing a graph or your sketch of a function, even if in the end you might have it slightly wrong. If you follow this menu, then you're demonstrating that you know the important steps to creating the sketch or the graph. Asymptotes, which we've just done. And obviously vertical asymptotes occur near any discontinuities, which you will have identified back up here in the domain. And horizontal asymptotes will occur by investigating what x is doing as you approach plus or minus infinity.